So today we're going to try to work out this big menacing problem. So I'll read it first off. It says limit as x goes to infinity of 1 plus 1 over x to the power of x radical negative 1 times radical 6 times the sum from when n equals 1 to infinity of 1 over n squared. So that looks like just a mess. But we're going to find some mathematical beauty in this creature right here. So let's take part by part. So this part first we can reduce a little bit. We can reduce it as limit as x goes to infinity of x plus 1 over x to the power of x. And now whenever there's a power of x, I always want to try to do natural log and then e to the power so it reduces. So I can go ahead and say this equals limit e to the power of limit as x approaches infinity x natural log x plus 1 over x. And I can do that because when I take natural log, one of the rules says I can take this exponent down front. So now we're going to find that this is an indeterminate form because this approaches infinity, the x, and this ln terms approaches 0. So it's an indeterminate form, so we use L'Hopital's rule, and when we use it once, we find that this whole limit right here goes to 1, so that e to the power of 1 is e. So we found our first important result. This big, menacing, complicated looking thing right here inside the green brackets is nothing but the number e. So what's next? Well, the next result is pretty easy. The square root of negative 1, well, we know that as I. And what about this menacing thing right here? Well, pi is a very interesting thing because pi, we always say it's the ratio of the circumference to the diameter. Like if you have a circle, pi equals circumference over diameter. And that's all well and good, but the realistic thing is for years people have been looking for numeric answers for pi, something they can write down physically, like some kind of equation with numbers, and they'll get pi from it. And people have been finding stuff, good approximation, but it turns out that there is a certain series that will give you pi exactly. So it turns out that if you do the series from n equals 1 to infinity of 1 over n squared, so that means it's 1 over 1 plus 1 over 2 squared plus 1 over 3 squared and so on to infinity, you're going to get pi squared over 6. So that if you multiply this series by 6, then this goes away. And if you take the square root of it, then the squared goes away and you just get pi. And that's exactly what I've written right there. Therefore, this thing in the new green brackets is nothing but pi. So if we write everything, if we simplify everything we've written, we get that the original equation is e to the I pi. And that equals negative 1 by Euler's formula.